Chapter 7, Review 1. These first four problems here are multiplying and or dividing rational expressions. So we always want to first factor first on these. So taking a look at this one here, they have x in common. So I'm going to pull out an x. We're left with 2x minus 3. Down here, this would be x plus 3, x minus 3. Alright, right here we have x plus 3, x minus 2. And down low here, this is a binomial, so we're going to GCF this. 3x, and then we're left with x minus 2. And here's the deal about multiplication is you can just go straight across. So we can start canceling everything. And we're going to be doing lots of canceling when we're multiplying and dividing rational expressions. X plus 3's cancel, these x's cancel. Alright, here's what we got left. 2x minus 3 up top. Over 3 times x minus 3 down low. And for me, go ahead and leave those fully factored. Number 2. This is division. So we're going to keep change flip. We're going to keep this the way it is. We're going to change this into multiplication. And we're going to flip this second one. Why? Because the definition of division is multiplying by the reciprocal. So 2x cubed y squared over 4x to the 4th z. If you want, you can simplify before at this step here, you could do 2/4 is 1/2. You don't have to. I like to keep change flip first and then start mathing. Alright. Then anytime I'm doing a fraction times a fraction and it's something like this, they're all monomials, I like to simplify the numerator. 2 times 14 is 28. X cubed times x is x to the 4th. Y squared, z. Now simplify the denominator. 4 times 2 is 8. X to the 4th times x is x to the 5th. Z, y. So let's go alphabetical. Alright, I'm going to split these up one at a time. What's that going to simplify to? That's going to be 14 over 4 or 7 over 2. What's this going to simplify to? Bottom's bigger than the top. 5 minus 4 is 1. What's this going to simplify to? Top is bigger than the bottom. 2 minus 1 is 1. And the z's just cancel. You're done. Next, number 3. I like to keep change flip it even before I factor, unless I combine them into one step. But I'm not going to do that because some people might find it confusing. So let's keep change flip it first. Keep this the same, change that to multiplication. Flip this one. Alright, let's factor this. That's going to be x minus 6 times x minus 3. Factor this. It's a binomial, so that's going to be x times x minus 4. Binomials will typically be GCF factoring. Let's factor this. X plus 2 times x plus 4. And let's factor this. X minus 3 times x plus 2. And basically now we just multiply straight across on the top and the bottom, which means we can start chopping. So x minus 3, x minus 3, x plus 2, x plus 2. Alright, we are left with x minus 6 times x plus 4 over x times x minus 4. That's it. Number 4, this is division. This is a super fraction. This means division, so we're going to keep this. We're going to change this to multiplication. We're going to flip that. So what we're working with is 3x squared minus 75 over 6x squared plus 30x times 9x squared plus 45x over 4x minus 20. Alright, let's factor this one. They have 3 in common. And oh, check this out. That's a difference of perfect squares. So let's go straight to x minus 5x plus 5. Alright, this is a binomial, so GCF it. 6x times x plus 5. Binomial, 9x times x plus 5. Binomial, 4 times x minus 5. It's multiplying, so let's start chopping. It's up to you, your comfort level of how much you can chop in one step. X divided by x, 3 divided by 6 is 1 over 2. So I'm going to consolidate here. I've got 1 times 9 times x plus 5. 2 times 4. And that's as far as we can go. Alright, now 5 through 8 we are adding or subtracting, and these you do not want to cancel until you get to the end. Sometimes you can cancel. Alright, so we want to find the LCD, which is going to be 2x times x minus 2. That means that this first fraction here, x minus 1 over 2x, is missing this part of our LCD. Plus x plus 1 over x minus 2. Oops. I like to put parentheses around my binomials because if these go down, they gotta go down together. So x minus 2. This one here is missing the 2x part. Foil this thing. You get x squared minus 3x plus 2 distribute this thing, you get 2x squared and the way you add fractions is you add the numerator and keep the common denominator. So we're working with x squared minus 3x plus 2 plus 2x squared plus 2x. And this is all over our 2x times x minus 2. Combine like terms. X squared plus 2x squared is 3x squared. Minus 3x plus 2x is minus x plus 2 over 2x times x minus 2. Now, we need to check to see if we can factor and then cancel any factors. So, that numerator, 3 times 2 is 6. Factors of 6 equal -1 are nothing, because they have to both be positive or both be negative. So we're done. Alright, now, before I move on, listen, I don't usually show this step. I usually jump straight to here, and that's what I'm going to do from now on. Alright, our LCD is x plus 1 times x minus 3. So this first term is missing our x minus 3. And our second term is missing our x plus 1. Distribute this. X times x is x squared minus 3x. Distribute this. Positive 2x. Positive 2. All over the LCD. Okay, combine like terms. Factor if you can after you combine like terms. So x squared minus x plus 2 over x minus 3 times x plus 1. Now we can factor this. It turns out we don't have to. Oh no, wait a minute. I think we do. Let's check this. X squared plus x minus 2x would be negative x. Oh, plus 2. We can't factor it. I'm glad I made that mistake, so you could see it. Coming back here, we're done. Alright, number 7. Our LCD is x minus 2 times x plus 3. So this first one is missing the x plus 3 part. And what I like to do when I'm subtracting a monomial term is change it to plus negative. That works out pretty nice. So we have negative 4 over x plus 3. This one's missing our x minus 2. Alright. Distribute 3x squared plus 9x. Negative 4x plus 8. Over our LCD. Combine like terms. Alright, can we factor that top 24? Factors of positive 24 that add to 5 don't exist. Okay, so we're done. Notice we have not canceled on any of these yet. When we're adding and subtracting, we don't cancel unless we have to at the end. So to kick this one off, I'm going to change that to plus negative 8. If this is not a monomial, you can't do that. You just have to do minus and then put everything after the minus in parentheses. Okay, our LCD is x minus 2. This one's got x minus 2 times x plus 4. So to make these, or x plus 2, to make these the same, they both need x minus 2 times x plus 2. That's our LCD. So only our first term is missing part of the least common denominator here. Got to multiply this by x plus 2 over x plus 2. how you want to treat this second term is up to you in regards to, do you want to just leave it x squared minus 4? I don't. I like to have everything fully factored in case I got to graph it. Alright, 2x plus 4 plus negative 8 is going to give us 2x minus 4 now this one we can factor GCF that numerator 2 times x minus 2, and it turns out we can cancel on this one, but only at the end. Number 9. Y varies directly as x if y equals 4. When x equals negative 2, find k. Varies directly, we're working with y equals kx. Y is 4. X is negative 2. Solve that for k. Okay, negative 2 is k. Write the equation that relates y and x. Y equals negative 2x. What is y when x equals 30? Y equals negative 2 times 30, which is negative 60. Find x when y equals 100. So 100 equals negative 2x. Negative 50 equals x. Number 10, the distance a car can travel on a certain amount of fuel varies inversely with its speed. If a car traveling 50 miles per hour can travel 336 miles on 10 gallons of fuel, how far could the car travel on 10 gallons of fuel at 60 miles per hour? So this makes this problem inverse right here. Also because it says varies inversely. Alright. So inverse is y equals k over x. However, we don't have y and we don't have x. We have distance, d, and speed. I'm going to call that r for rate because my s's look like 5s. So we're working with the formula d equals k over r. Then substitute. We got 50, 336 miles. So, distance is 336 equals k over 50, the speed. Multiply both sides by 50, and you get 16,800 equals k. So now we have this equation. D equals 16,800 over r. And now we're saying that the r is 60 miles per hour. So the distance it could travel at that speed is 280 miles. I guess it's not a very fuel efficient vehicle when you increase your speed. Alright, number 11. Oh yeah, so these are different than the first 4 and the second 4 because of this word solve, which involves that sign, equal sign. When you have an equal sign, then you're going to end up with x equals something. So we're going to kind of treat this like a plus and minus. Let's find the LCD first. Think of that as 3 over 1. So the LCD is x plus 4 times x minus 3. So here's my original first term, and the thing that's missing from our LCD is x minus 3. change that to plus -2 over x minus 3. The thing that's missing from my LCD is x plus 4. Then this equals 3 over 1. And we're missing both things from the LCD. X minus 3 times x plus 4. Now, I'm going to go ahead and FOIL this because up top it's a little easier to do 3 times x squared plus x minus 12. If that's confusing, don't do it that way. Alright, so 6x minus 18 plus -2x minus 8 over x plus 4 times x minus 3 equals 3x squared plus 3x minus 36 over x plus 4 times x minus 3. Our next step then is to multiply both sides of the equal sign by our LCD. The reason why we do that is because these then cancel. Alright? However, I like to just think of it like this. From henceforth, I'll be working with the numerators and setting them equal. So we've got 6x minus 18 minus 2x minus 8 equals 3x squared plus 3x minus 36. I should have simplified this. We're going to have 4x minus 26 equals 3x squared plus 3x minus 36. So 0 equals 3x squared minus x minus 10. Alright, can we factor this? 3 times 10 is -10 is -30. -6 times +5 is -30, and it adds to -1. So yeah, we can factor this. 0 equals x 3x, and then what are factors of 10 that I can use? Well, I need a 6, right? So 2 times 5 is 10. This is -6. This is +5, so sure enough that works. X minus 2 equals 0, x is 2. 3x plus 5 equals 0. 3x is -5. X is -5/3. If we sub those back in, do any of them make our denominators 0 in the original? No and no. It have to be -4 and +3. So typically that means here in algebra 2, we're safe. Those are both legitimate answers. Alright, number 12, I'm going to do this differently because I hate cross multiplying. So I'm going to find an LCD. It's 3 times x minus 2. So this first term here is missing the x minus 2 part. This one here is missing the 3 part. And we get x squared minus 2x over 3 times x minus 2 equals 15 over 3 times x minus 2. And then I'm just going to do this the same way. So remember, typically, mathematically, here's what we're doing. Multiply everything by 3 times x minus 2 and it gets rid of these. Okay? But I like to just say, deal with the top. X squared minus 2x equals 15. X squared minus 2x minus 15 equals 0. x minus 5 times x plus 3 equals 0. So x is 5 and x is negative 3. Now, if we plug these into the original, yeah, it works. Put negative 3 into the original, negative 5, yeah, it works. Okay? So they both work. Alright, here's the big monster. But it's not too bad because the LCD is just x plus 3 times x minus 2. So this first term then is missing the x minus 2 part. Let's go ahead and treat this like that. So plus negative 3 over x minus 2. It's missing the x plus 3 part. And that's going to equal 5 over and what's cool about this now is we can actually from this point forward just deal with the numerator. So I'm going to do that. 5x minus 10 minus 3x minus 9 equals 5. 2x minus 19 equals 5. Two x is 24. So x is 12. Plugging that into the original, 15, 10, 144 plus 12 minus 6 is not 0. So there you go. It works. Alice can paint a room in 8 hours. Her assistant can paint the same room in 12 hours. How long will it take if the two of them work together? Well, one room every 8 hours plus one room every 12 hours. And we need it to equal one job. So we need some LCDs. 24 is the LCD that I can think of. I wanted a different color there. So we got 3x plus 2x divided by 24 equals 1. 5x equals 24. X equals 24 fifths. Hours, now that would be 4 4/5 of an hour. Number 15, graphing. Alright, to find a whole, something's got to cancel. So first factor first. X squared plus 2x minus 8 factors into x plus 4 times x minus 2. And this is all over x minus 2. Something does cancel. We have a whole. To find the x term for your whole, you take what you just canceled and set it equal to 0. So for the whole, x is 2. To find the y term for your whole, you take what's left. So we're working now with y equals x plus 4. And we just found that x is 2. 2 plus 4 is 6. So we have a whole at 2, 6. 2, 6. Want to put a hole there so that we don't forget it. Vertical asymptotes you find by setting the denominator equal to 0. Well, check it. We don't have a denominator anymore, so there are no vertical asymptotes. Horizontal asymptote you find by comparing the degree on top to the degree on the bottom, and I like to go back to the original for this. If the degree on top is larger than the degree on the bottom, we don't have a rule because there are no horizontal asymptotes. Now, x-intercept, y-intercept, domain and range, I like to graph before I find those. If you would like, you can put this in your graphing calculator and fill out a table. But y equals x plus 4, that's mx plus b. b is 4, m is 1. And no wonder we didn't have any horizontal or vertical asymptotes, because lines don't have asymptotes. The x-intercept occurs where we cross the x-axis, so that's -4, 0. The y-intercept occurs where we cross the y-axis, that's 0, 4. The domain is all real numbers, but x cannot equal 2. There's a hole when x equals 2. Range is all real numbers, but y cannot equal 6. There's a hole when y equals 6. Okay, this one here, nothing cancels, so we don't have a hole. Now to find the vertical asymptotes, you always take the denominator and set it equal to 0. So x plus 1 equals 0, x equals -1. And I like to graph them when I find them. Okay, horizontal asymptotes, you look at the degree up top compared to the degree on the bottom. When the degrees are the same, then you have a y equals the ratio of the coefficients, 3/1, which is 3. So we have two asymptotes here. Let's graph it. And this one I would probably use a graphing calculator and look at the table. -1 is going to give you an -2, -3. I didn't leave space, so let's do -4 out here. 0, 1, 2. If I put in 0 for x, I get 0/1, which is 0. 1 for x is 3/2, which is 1.5. 2 for x is 6/3, which is 2. If I put in -2, I get -6/-1, which is 6. -9 over -2 is 4.5. -12 over -3 is 3. So we got -4, 3. That can't be correct. It's 4. Yeah, use a calculator. -4, 4. Right there. -2, 6 is here. -3, 4.5 is there. This is what we got going on. Alright, 0, 0, 1, 1.5, 2, 2. Got this going on. Okay, x-intercept. Where do we cross the x-axis? Right here. 0, 0. Y-intercept. Where do we cross the y-axis? Right here. At 0, 0. Domain, all real numbers. But here we have an asymptote. So x cannot equal -1. Range, all real numbers, but here we have an asymptote. So y cannot equal 3. F of x equals 2/x plus 5. Nothing cancels, so there is no hole. Vertical asymptotes. We take x plus 5 and set it equal to 0. Always take the denominator equal to 0. We get x is -5. Alright, x is -5. Horizontal asymptotes. We have no x on top, x to the first on the bottom. When the degree on the top is less than the degree on the bottom, our asymptote is y equals 0. Alright, let's say the x-intercept, y-intercept till we graph. Let's graph it up. x, y, -5, -4, -3, -2. Put in -4, I get 2/1 is 2. Put in -3, I get 2/2 is 1. Put in -2, I get 2/3. Put in -6, I get 2/-1. Put in -7. I get 2 over -2. Put in -8. I get 2 over -3. -8, -2/3, about a third. -7, -1 is third. -6, -2 is third. Boop. All right, -4/2. Right there. -3/1 is there. -2 2/3 is there. All right. So where does our graph cross the x-axis? Nowhere. And that makes sense because it's an asymptote. Where does our graph cross the y-axis? Right here. Uh-oh, I don't know what that is. Okay? When we are looking for a y-intercept and we're not sure exactly what it is, we want to let x equals 0. So let's do this in green. So y equals 2 over 0 plus 5 is 2/5. So we have a y-intercept at 0, 2/5. Domain, all real numbers. Well, x cannot equal -5. Again, these should match. Range, all real numbers. Well, y cannot equal 0.